Okay, today in class we started looking at scientific notation. This is a method that helps us use very, very, very small numbers and very, very, very large numbers in calculations, making the calculations a lot easier. I'm going to show you how to take numbers and put them into scientific notation, and the other way around, taking numbers that are already in scientific notation and writing out the original number. So first, we'll look at the one that we did in class. So we have 4,300,000,000. And I don't have a unit right now, but that doesn't really matter at this point. So 4,300,000,000 is a really difficult number to work with if we had to multiply it by anything. It's too many zeros to keep track of. So what we want to do with scientific notation is make it so that this number is at least greater than or equal to 1, but also it has to be less than 10. Always. So right now, the decimal place for this number is at the very end. When the decimal place is not written, it means that it is understood. It is at the very end. In order for this number to be greater than or equal to 1, but still less than 10, our decimal place is going to have to go here between the 4 and the 3. So now if we look at it, 4.3 is a number between 1 and 10. So we would write 4.3. However, we want to see how many times did this decimal place, or how many positions did this decimal place have to move. So we'll just count. 1, 2, 3, 4, 5, 6, 7, 8, 9. It had to move 9 times. So what we do with scientific notation is write times 10 to the 9th. Let's think about this conceptually for a second. If you take 4.3 and you multiply it by 10, so 4.3 times 10, you should get 43. If you take that and multiply by 10, you get 430. That multiplied by 10 is 4,300. To get from 4.3 to 4,300,000,000, you would have to do this 9 times. That's what that exponent means. You would have to do it 9 times. I'm not going to do it all 9 times. That's too crazy. Let's also do a very, very, very small number for an example. So let's try 0.0000298. So we're going to do the exact same thing, except that here we already know where the decimal is. It's right there. But to make it so that our value is between 1 and 10, we want this decimal to be here, after the 2. The way we figure that out is remember, all of these zeros are insignificant, so you go to the very first significant number and put your decimal after it. So now you have 2.98. And 2.98 is between 1 and 10. So 2.98. Again, we're going to do the same thing as before. We're going to count how many positions this decimal had to move. So from here to here. 1, 2, 3, 4, 5, 6. So this is going to be times 10 to the 6th. However, since this is a very, very small number, and this is a very, very large number, these exponents cannot be the same order of magnitude. They can't both be positive. When you have a very, very small number, the exponent will actually be negative. And what that means is that instead of multiplying like we were doing here, this really just means you're dividing. So if you take 2.98 divided by 10, you would have 0.298. Divided by 10 again, you would have 0.0298. Divided by 10 again, you would have 0.00298. So again, if we wanted to go from 2.98 to this very, very small number, 0.0000298, you would have to divide by 10 6 times. Okay. Now, what if we are given a number that is in scientific notation and you have to take it out of scientific notation? So let's try those real quick. If I give you 4.7 times 10 to the fourth. This number is positive. That's the first thing that I want to see and notice. That number is positive. Therefore, the value out of scientific notation is going to be a very large value. You're going to multiply 4.7 times 10 4 times. And the easiest way to do that is just to take this decimal place and move it over 4 times. So you do 1, 2, 3, 4. And now we're just kind of ignoring these things over here. And all those positions, those empty positions, you fill in with a 0. So 4.7 times 10 to the fourth is the same thing as 47, 0, 0, 0, 47,000. All right. What if we had a very, very small number? We have 9.4 times 10 to the negative 7. You're going to do the same thing, except that now, instead of moving the decimal over to the right, which would make this number bigger, and remember, moving it to the right means you're multiplying it. But when you have negative 7, you're going to be dividing. So you're going to divide 9.4 by 10 7 times. So you're going to move this decimal place over 7 times. So to do that, 1, 2, 3, 4, 5, 6, 7. I didn't leave myself very much room. Fill in the zeros. And then ultimately what you get, I'm going to rewrite it real quick, is 0.00000094. So notice that would be a very difficult number to work with, and it's a huge convenience to be able to put it into scientific notation and work with it that way. Now let's look at not addition and subtraction, because I told you in class that addition and subtraction is very challenging with scientific notation. So we started with multiplication and division. These were actually a lot simpler. So let's look at multiplication first. And let's say that we have two numbers in scientific notation. We'll make some up here. 2.7, that's really too thick. 2.37 times 10 to the fourth. Multiply that by 3.9 times 10 to the fifth. When we are multiplying numbers that are in scientific notation, you add, or I'm sorry, I misspoke. You multiply the coefficients and you add the exponents. So first you do 2.37 times 3.9, and you should get, if you do it in your calculator, you'll get 9.243. And then you add your exponents. So 4 plus 5 equals 9. So then your answer would be simply those two put together. 9.243 times 10 to the ninth. Now I want you to notice that this is in scientific notation. It is a number between 1 and 10, so you're fine there. However, this has too many sig figs. Our initial values had 3 sig figs and 2 sig figs. So this number, this coefficient, can only have 2 sig figs. So you would round to 9.2 times 10 to the ninth. All right. Division is also very simple. Look at that. So with division, let's do 5.42 times 10 to the ninth divided by 6.2 times 10 to the fourth. Here, you're going to divide the coefficients, so these two numbers in the front, and then you're going to subtract 9, or you're going to subtract 4 from 9. You subtract the exponent in the numerator minus the exponent in the denominator, rather than adding like we did with multiplication. So 5.42 divided by 6.2, if you do that in your calculator, you should get about 0.8741935,484. Now that is a pretty ridiculous number, but that is what your calculator will give you. Notice how many sig figs there are. We will definitely have to change that, but you don't change that until the very end. So we've got our coefficient. To figure out our exponent, you do 9 minus 4 equals 5. So it's going to be this coefficient times 10 to the 5th. Now once you've done that, you can round it to the correct number of sig figs. And in our initial values, we had 3 sig figs here and 2 here. So we're going to chop this down to just 2 sig figs. So you should have 0.87 times 10 to the 5th. All right. So in the next video, I'm going to show you how to do addition and subtraction. They are much more difficult. However, fortunately, they have the same rule. So watch that one next.